Hi guys, this is Caveman Safe Jawad coming back to you with another code complexity reduction example. This time we're going to use polymorphism to reduce code complexity and show you why it's a good idea to use such a method. Well, let's go to the screen. So this is an application that does animal sounds based on the animal, and it's written in Java. Straightforward. You have a method called getAnimalSound and gets an animal name. So based on this animal name, it's going to use a switch case to choose the right sound that the animal makes. But this is not the best way. So sure, it works. Let's see. Run application test. And it's going to run a test. Yeah, I think everything's fine. If we go to the test of the cat and we say, okay, so a cat should meow. Said, well, the cat did meow, meow, meow. Very nice. But the thing is, about this application, the cyclomatic complexity tends to get higher and higher the more cases you add. What is the complexity? I'm talking about cyclomatic complexity, and that means that it calculates, the cyclomatic complexity model calculates how many paths your application is going to be using to execute a certain problem or program. And in this case, it's going to calculate how many ins and how many outs. So there's basically one in, then there's an if statement. If it's no, then it returns something, and otherwise it continues to the switch statements, and it can be any one of these answers that you will get if it receives a string animal. Now, the problem with this is the following. This is a block of code. This is a block of code. And these blocks of code, if you calculate them together, they are going to mount up to a certain complexity. At some point, it gets too high because there are many animals. Too many animals. And if you keep putting them here, or one of them might go extinct, then you have to remove someone every time you're touching this block of code. Always the same. That means it is error prone. And to fix this, we're going to use polymorphism. So you don't add to the complexity at all, and you can expand infinitely as many animals as you can think of, even imaginable ones like unicorns. I don't think they exist, so imaginable, yeah. Anyhow, to do this, I wrote a small program. Instead of this big method, we're going to give every animal its own class. So let's switch to the solution. So here's our application. In this case, we don't receive a string anymore, we receive an animal. And an animal, that's what all the animals are actually. They are an implementation of the interface called animal. So instead of the switch case in which we get a string called animal and then putting a name back, we are going to create classes of animals that implement the interface animal. And interface animal says it's a contract. So every class that implements the animal interface has these two methods. So for example, cat will have a get name that returns cat and has a get sound that returns a meow. That's the sound that the cat makes. So anyhow, if we do it this way, if we do that, the overall complexity will go down. So the complexity in this case went from 13 to 6, and the method itself from 13 to 5, I think from 12 to 5. And all the classes have actually no complexity at all, because it's getters and implementations, right? So the overall complexity has gone down, the cyclomatic complexity, and you can infinitely add as many animals and as many other magical creatures as you want. That way, complexity is down and your code is easier to change, modify, expand, whatever. So have fun, enjoy it, and please practice at home. I am going to go gardening. Thank you very much for watching, and don't sit behind the computer too long. It tends to hurt your back and it's not very good for you.